Hey everyone. So I was asked today how to make a simple moving platform for a platformer type game. So I thought I'd put together a quick video tutorial to show you one way to do that. So I've put one together, and what I'll do after I've demonstrated how it works is we'll pull it apart and build it again. So if I hit play in Unity right now, you can see we've got a moving platform that alternates between the position of this green wire cube and this red wire cube. And if you look at the variables we've got access to in the inspector, we can change the speed of the platform just by moving this platform speed. And if we stop the editor for a minute, we can grab the start position and move it closer. And if we run it again, you'll see now the platform moves to the new start position instead. So I'm going to delete everything at this point. We'll delete the script as well. And I'll show you how to make that from scratch. So all we're going to leave in the scene is the main camera, which is still in its default position for a new project. I've added a directional light, and we've got a cube here, which is just to represent the player. And that cube's got a rigid body on it with gravity enabled, so that it falls when we play. And that's just to make sure that our platform actually moves the player as we go. So we're going to start by adding an empty. And we'll rename this to moving platform. And then we're going to add underneath that a cube. So we'll grab that cube and put it under here. We'll make sure the moving platform object, just going back to it, is at 0, 0, 0, so the origin. And then we're going to set the X scale on the cube to 6, just to give it some width like the platform you saw a minute ago. And we'll rename the cube to platform. We're just going to add 2 more empties now, and these are going to be the reference points in the world for where the platform moves to and from. So we're going to call these start position, and we'll just duplicate that one and rename the duplicate to end position. And now we'll just make sure they're all at 0, 0, 0 for now, underneath the moving platform. So there we go. Okay, now we're going to add our script. So we'll go create, right click in the project folder, create C# script, and we'll call this moving platform. And then we'll drag the script and we'll put it on the top object here called moving platform. Other than that, we're ready to go. So we'll just look at our script now. I'm just going to delete this code to make it a bit more readable, and we're going to add 3 fields at the start, and I'm going to do that. We're going to expose these in the inspector, and I'm going to do that using serialized field. Now you can instead just use public, but I tend to only use public if I actually want a field to be public, and in this case these fields don't need to be public. I just need them to show up in the inspector. So you're welcome to do either. If you want to use public instead, you can just write it like public transform platform, and you can delete that altogether. But I'm going to stick with using serialized fields. So we're going to expose a field called platform, which is a transform. We're going to expose another transform called start transform, and one more called end transform. Now we could link these up programmatically, but because I want to draw some other stuff while the editor's running, sometimes you can run into a bit of a trouble with the editor executing start events, so we're just going to do it this way for now. So once we tab back into Unity, provided there are no errors in our code, you should see the 3 fields exposed here. So we're just going to drag platform to platform, start position to start transform, and end position to end transform. With that done, what we're going to do is we want to now visualize the end and start position transforms in the scene view in the editor. So I'll just move the start position a bit to the left and the end position a bit to the right so we can see what happens when we do that. And we'll tab back here, and what we're going to do is we're going to use one of the methods we were inheriting from mono behavior up here called onDraw Gizmos. And so what onDraw Gizmos allows us to do is draw some additional primitives and other sort of visual aids in the scene editor, just to help us sort of understand our levels and sort of build tools to help us visualize and develop levels in an easier way. So the first thing we're going to do in onDraw Gizmos is we're going to write gizmos.draw wire cube, and draw wire cube takes two arguments. It needs a vector 3 for its center position and then a vector 3 for its size, which is essentially a vector representing its scale. So for the center position, we're going to use the start transform dot position, and for its size, we're going to use our platforms. Local scale, which of course we set earlier to x is 6, y is 1, z is 1. So if we look in the editor now, you'll see once that code compiles, we should see we've now got a wireframed cube drawn at the location of our start position. And we can move that around now and visually see in our scene where it is. So now we're going to go ahead and just copy that line and paste it and change start transform to end transform, and that should give us both of our positions drawn now. Now the next step's entirely optional, but it makes things a bit clearer, and that is to make the start position cube green and the end position cube red. So to do that, we just go back here and we add gizmos.color, and we set that to color top green, which is a predefined color we have access to, and then we're going to do exactly the same for the end transform, except make it red. So basically what happens here is the gizmo drawing color gets set to green and it draws the wire cube for our start position, and then the gizmo drawing color gets set to red and it draws the wire cube for our end position. So if we tab back to the editor now, you'll see they've now been drawn red and green, which is good, and now we can sort of move on to making our platform move. So we're using physics for this platformer. The cube is a rigid body, so at the moment when we run it, the cube falls onto the platform. What we want to do in order to make the platform move the cube as it moves is we want to make the platform a rigid body as well. So we're going to go to the platform game object, and we can either add a component down here and type rigid body, or we can go up to the component menu and go to physics and click rigid body. And what we want to do is we want to turn off use gravity, and we want to tick is kinematic. So what is kinematic is going to do is it's going to stop it moving on its own accord. So if we run our game now, you'll see the cube still falls down and it lands on this our platform. So what we'll do from here is we'll just quickly look at how we move the platform in general. So we're going to do this in fixed update, which is another inherited method. And the reason we're going to do it in fixed update is Unity recommends that you do your physics adjustments in fixed update as opposed to update. So the difference between update and fixed update is that update sort of runs every time the frame is redrawn in Unity, so that depends entirely on your frames per second, whereas fixed update is run in a fixed time step, which you can define yourself under edit project settings time, And so by default, fixed update is set at 0.02 seconds, so it's run every 0.02 seconds. So in fixed update, we're going to move our platform. What we're first going to do is just set up another variable or field, and we're going to make this a float, and we're going to call it move speed or platform speed. And so this is going to be the platform speed in Unity units per second. So when we tab back to Unity, we'll now see that we've got this exposed value here, and we're going to set that to 2, which may or may not be a bit fast, we'll see. And in fixed update for now, what we're going to do is we're going to go platform.rigidbody. So we're accessing the rigid body component on our platform now by writing that. And we're going to use a method on the rigid body called move position. And I'll explain that in a minute. So move position just wants to know the final destination of the rigid body. So we're going to start by taking its position, and we're going to add, for the moment, we're just going to add the global, we'll add global right to it, and then we'll multiply that by our platform speed, which we've set up, and then we'll multiply that by time dot fixed delta time. So fixed delta time always returns the same value, and it's similar to delta time, except it always returns whatever the fixed time step value is. So in this case it's going to return 0.02, and that just lets us you don't need to multiply things in fixed update by time dot fixed delta time, but what it allows you to do is still work in units per second when you set the platform speed. Otherwise you would have to be setting the platform speed to units per fixed time step. And so it's a lot more intuitive to be able to still set that at Unity units per second. So if we tab back to our project now and hit play, you can now see we've got the platform moving right at 2 Unity units a second. So, sorry, not 2 at the moment. Yes, no, it is 2. So what we're going to do from here is, first I'm going to quickly explain why we're using this rigidbody.movePosition function rather than just translate. So the important thing about move position is, if we look at the Unity scripting reference, is move position acknowledges that when you're moving a physics object, we don't just want to teleport it to a new position by setting its transforms position. So what rigidbody.movePosition essentially does is it still iterates or steps the rigid body through a number of positions to get there, so that if it, say, collides with anything, it will still register that collision. And the other thing, more importantly, it does is that it carries our player character with it. If we just use transform.translate, what you'll see happening here is the platform will continue moving to the right and the character will stay still and then ultimately fall down as the platform moves off, which isn't the behavior we're after here. So that's why we're using rigidbody.movePosition. At this stage though, what we need to do is we need to actually set this up so that it moves in a direction towards one of the platforms and then stops when it gets to, a direction towards one of the positions and then stops and turns around. So what we're going to do in order to set that up is we need to replace this vector3.right with a vector which is a normalized vector always pointing in the direction of its current target. So we're going to add two more values here which we don't need to expose. One of them is going to be the direction vector, and the other one is going to be a destination, and the destination is going to be a transform, and ultimately the destination is going to either be start transform or end transform. So what we're going to do first is we're going to define a new method called setDestination, and our setDestination method is going to take one argument, which is going to be a transform, and we're going to call that dest. So what we'll do here is we'll set destination to dest. Whoops, I have misspelt it here. Sorry. So we'll just fix that. We'll set destination to dest. So we're basically updating this destination value, and then we will establish the direction based on its destination. So the in order to get a vector that's pointing towards a target vector, we take the target vector first, which in this case is going to be our destination.position, remembering that destination is a transform and it's either going to be end transform or start transform. So what we're saying here is either end transform or start transform's position, and we're going to subtract the platform's current position from it. Getting some bad autocompletes today. So we're going to take the platform's current position from it, subtract it, and then what we're going to do is we're going to use dot normalized. So what dot normalized is going to do is it's going to normalize the magnitude of that vector to 1, because this value here, sorry, I needed an equal sign here. This value here, destination.position minus platform.position, is going to be a vector with a magnitude, effectively the distance between the two. What we want to do is we just want to extract the x, y, and z values that give us a direction, as opposed to using it for distance purposes. So we're just going to normalize that, and we'll end up with a vector that's sort of pointing in the right direction but has a magnitude value of 1, and that will allow us to replace vector right with that value, which we can do now, direction, and we still have here a vector with a magnitude of 1, as was vector.right. So now what we need to do is we need to actually work out what the destination is in the start event. So it would be a nice, for now what we'll do is we'll just always make that the start transform, or the start for the starting position. So we're going to in the start method, which we also inherit from mono behavior. So this is run when an object is first sort of brought into the world. Now we're going to call our setDestination method, and for now we're just going to set it to the start transform. And then you'll see in our fixed update, what we're doing now is we're telling it to move in the direction it establishes based on what its destination is set to. So if we run this now, hopefully we'll see it move to the left, and that's what happens. Our next problem is, of course, that it keeps moving to the left and it never ever turns around. So what we're going to do to solve that is in our fixed update event, we're going to run a distance check to see if it's so close to the destination position that it should turn around. So in order to do that, we're going to write vector3.distance. So this is a method that allows us to provide two vectors as arguments, and it will return a float value, which is the distance between them. So we're going to check the distance between the platform position and the destination position. what we're going to do is, if it's less than the platform speed times time dot fixed delta time, then we're going to change our direction. So the reason we're comparing the distance and checking if it's less than platform speed times time dot fixed delta time is because this essentially represents the amount the platform moves per fixed update step. So there'll always be an instance in time where the distance is less than this value, and that is the appropriate time to turn around the platform and move it in the other direction. So if this occurs, what we do is we just need to now set our destination again, and we want to set it to the opposite destination to the one it's currently going to. And to do that, we can use the C# ternary operator. So the ternary operator looks at a condition, and in this case we're going to say destination equals, we'll say start transform. And this question mark here is our ternary operator, and what this does is we evaluate this destination equals start transform, and if the destination does currently equal the start transform, the ternary operator allows you to put in two values here. One of them is the value to use if this is true, and one of them is the value to use if it's false. So if the destination currently equals start transform, then we'd want to go to end transform, and then we use a colon to separate the two values, and in the case that destination equals start transform is false, then we want to make the destination start transform. And so wrapping this all up inside set destination will ultimately end up sending it one transform value. It'll be the end transform value if the destination is currently the start transform, and it will be the start transform value if it's not. So that effectively will keep alternating our between the two transforms. So if we now come back to Unity and run our project, you'll see we now have a platform that moves to the start transform and then turns around and moves to the end transform, and it will do this indefinitely. But one of the advantages of building it the way we have is that we're not limited to just left and right movement if we don't want. Say we set the end positions x value back to 0 and the start positions x value back to 0. We could now say make a vertical platform just by moving these vertically instead, and you'll now see that it will alternate between these two positions. We're also not limited to just using one axis at a time. We can move this red end position over here, and now once it's got to the start position, it'll just alternate diagonally between these two. And so you've got the basic setup now for a system that you can extend if you want and have a play with, but for now I'm going to leave it here. So thanks for watching.